Let's have first the constant rule. So the constant rule states that if f of x is equal to c, where c is any real number, then f prime of x is equal to 0. So the derivative of a constant is equal to 0. Let's illustrate. We have here the graph of f of x equals 3. So f of x equals 3 is just a horizontal line passing through the point 0, 3. So the slope of a horizontal line is 0. That is why the derivative of a function wherein it is equal to a constant is equal to 0. For example, I have here, find the derivative of f of x equals 3. So the derivative of f of x equals 3, or f prime of x is equal to 0. Next, find the derivative of f of x is equal to 7 pi. So 7 pi is a constant. So f prime of x is equal to 0. Next, we have f of x equals negative square root of 5. So square root of 5 is a constant, so f prime of x is equal to 0. So that's basic. You need to remember the derivative of a constant is equal to 0. Next, let's have the power rule. So the power rule states that if f of x is equal to x raised to n for any real number n, then f prime of x is equal to n x raised to n minus 1. So to repeat, we will place n in front of our variable and then subtract 1 from the exponent. So this power rule works for any power. It may be positive, negative, or a fraction. Let's have our examples. So first here, find the derivative of f of x is equal to x raised to 6. So here we can apply the power rule. Our n is equal to 6, so we have 6x, and minus 1 is 5. So the derivative of x raised to 6 is 6x raised to 5. Next example, we have g of x is equal to x raised to 4. So our n here is 4. So we have g prime of x is equal to 4. X raised to 4 minus 1, that is 3. So g prime of x is 4x cubed. Next, we have here f of x is equal to x raised to negative 3. So following the power rule, f prime of x is equal to negative 3x raised to negative 3 minus 1, that's negative 4. Rewriting, we have negative 3 over x raised to 4. Okay, we have here our next example. We have h of x is equal to x raised to 1/2. This time, our exponent is a fraction. So h prime of x is just equal to 1/2 x. 1/2 minus 1 is negative 1/2. Okay, we can rewrite our answer as 1 over 2 square root of x. And this is our derivative. Now let's have the constant times the function. Let c be any constant. So if g of x is equal to c times f of x, then g prime of x is equal to c times f prime of x. Let's have our examples. So we have here f of x equals 4x cubed. So 4 here is our c, 4 is the constant. So f prime of x is equal to 4 times, alright, the derivative of x cubed. Now, x cubed, following the product rule, we have here 3x squared. Alright, so multiplying, we have 12x squared, and that is the derivative of our function. Let's have example 2. We have here g of x is equal to negative 2x raised to 4. Okay, here our constant in this function is negative 2. So we have here negative 2 times the derivative of x raised to 4 following the power rule. We have 4x, 4 minus 1 is 3. So g prime of x is equal to negative 2 times 4, that's negative 8x cubed, and that is our derivative. Next, let's have our third example. We have h of x is equal to 3x raised to negative 2. So here our c is equal to 3. So h prime of x is equal to 3 times the derivative of x raised to negative 2. So that's negative 2x, negative 2 minus 1 is negative 3. So we have here 3 times negative 2 is 6 raised to negative 3. We write, we have negative 6 over x cubed, and that is now our final answer. Next we have k of x is equal to 3/4 x squared. So here our c is 3/4. So just follow. We have here k prime of x is equal to 3/4 times the derivative of x squared. So you have 2x. So you multiply, we just have here 3 times 2x. We have 6x over 4. You simplify, we have there 3x over 2. And that is our derivative. Alright, now let's have the sum and difference rule. So the sum and difference rule states that if f of x is equal to g of x plus minus h of x, then f prime of x is equal to g prime of x plus minus h prime of x. Or simply, all you need to do is to differentiate each term in your expression. So for example, I have here f of x is equal to 3x cubed plus 8x squared. So here f prime of x is equal to, okay, differentiate first our first term, which is 3x cubed. So following the constant times the multiple rule, so you have here, constant here is 3, so you have here 3 times the derivative of x cubed. So following the power rule, so you have here x cubed, that's just 3x, 3 minus 1 is 2. Okay, plus still 8x squared, we have here the derivative of constant times the multiple rule. So you have here 8 times the derivative of x squared, which is just 2x. 2 minus 1 is 1, so just 2x. Now you simplify, so we have f prime of x is equal to 3 times 3, that's 9x squared, plus 8 times 2, that is 16x. And this is our final answer. Okay? Next example, let's have g of x is equal to negative 3x raised to 4 minus 8x squared. Okay, let's have plus 1. Okay, plus 1. So differentiate each term. So you just have here g prime of x is equal to, still apply the constant multiple rule in the first term. So you have here negative 3 times, okay, derivative of x raised to 4. So that's 4x raised to 4 minus 1 is 3. Okay, minus 8 times it with the derivative of x squared, which is 2x, plus the derivative of 1, which is 0. So g prime of x is equal to negative 3 times 4, that's negative 12x cubed, negative 8 times 2, that's negative 16x plus 0. So now this is our final answer. Okay, and lastly, let's have here h of x is equal to 4x raised to negative 2 minus 1. Okay, so h prime of x, first let's differentiate our first term, applying the constant times the multiple rule. You have here 4 times the derivative of x raised to negative 2, so that is negative 2x, and then negative 2 minus 1 is negative 3, minus the derivative of 1, which is 0. So what we have left here is, okay, 4 times negative 2, that's negative 8x raised to negative 3. Okay, now we can rewrite our expression here. So rewriting, we have here negative 8 over x cubed. This is an application of the laws of exponents. So this is now our derivative. Now let's have the product rule. So the product rule states that if f of x equals g of x times h of x, then f prime of x is equal to g of x times h of x plus h of x times g prime of x. Okay, so let's have here our example. So first, let's have f of x is equal to 3x times 4x squared plus 1. Okay, how do we get the derivative of this function? So first thing is we need to identify first our g of x. So here, our g of x is 3x, and our h of x is 4x squared plus 1. Okay, this is our h of x. All right, so writing now, g of x here is equal to 3x. So find the derivative of g of x. We have here, okay, constant times a multiple rule. So you have 3 times the derivative of x, which is 1. So 3 times 1 is equal to 3, and that's the derivative of g of x. Now, let's go to h of x. Our h of x here is equal to 4x squared plus 1. Now, getting the derivative of h of x, that is, okay, for the first term, applying the constant multiple rule. So you have here 4 times the derivative of x squared, which is just 2x, okay, plus the derivative of 1, which is 0. So you simplify h of x here, h prime of x is equal to 8x. And this is now the derivative of h of x. So now that we have identified now the derivatives of g of x and h of x in our function, we will now solve for the derivative of the entire f of x. So f prime of x is equal to, first given here in our formula, g of x. Our g of x here is 3x, so we write 3x times the derivative of h of x. Now, derivative of h of x is 8x, so times 8x plus h of x, which is 4x squared, plus 1 times the derivative of h of x, of g of x, which is 3. All right? You multiply now, so you have here 3x times 8x. This is 24x squared plus, okay, distribute 3 to our binomial. This is 12x squared plus 3. And combining like terms, our final answer will be 36x squared plus 3. Okay, now let's have another example. Find the derivative of f of x is equal to x plus 1 times x squared minus x. All right, so first let's identify our g of x. Our g of x here, that's x plus 1. So get the derivative of g of x. We have here derivative of x is 1 plus the derivative of 1, which is 0. So our derivative is just 1. Now let's go to h of x. Our h of x here is this factor of our function. So you have here x squared minus x. So h prime of x is equal to derivative of x squared, that is just 2x, minus the derivative of x, which is 1. Now that we have identified derivative of g of x and derivative of h of x, then we can now proceed into finding the derivative of the entire function f of x. So we have here f of x is equal to, just follow the formula. First we have g of x. Our g of x here is x plus 1 times h prime of x. H prime of x is equal to 2x minus 1 plus h of x, which is x squared minus x, and g prime of x, which is 1. Okay, let's multiply. So we have here x plus 1 times 2x minus 1. So we have here 2x squared minus x plus 2x minus 1. Okay, plus x squared minus x times 1 is just x squared minus x. Okay, this time you combine like terms. So I have here 2x squared and x plus x squared. This is 3x squared. And then at negative x minus x plus 2x is just 0, okay, minus 1. Again, let's write it. We have here negative x plus 2x. That's x minus x, so this is just 0. So what's left here is only negative 1. So our derivative now of f of x is equal to 3x squared minus 1. Okay? So that's how you find the derivative of a function applying the product rule. Now let's have the quotient rule. So the quotient rule states that if f of x is equal to g of x over h of x, and both g prime of x and h prime of x exist, and if h of x is not equal to 0, then f prime of x is equal to h of x times g prime of x minus g of x times h prime of x all over x of h of x squared. Okay, let's have an example. Find the derivative of f of x is equal to x over x plus, okay, x squared plus 1. All right, here in our example, our h of x, our g of x is equal to x. Okay, so we have here g of x is equal to x. So the derivative of g of x is just equal to 1. Next, let's have the h of x. Our h of x here is x squared plus 1. So here we have h of x is equal to x squared plus 1. So h prime of x is just equal to derivative of x squared. That is 2x derivative of 1 is 0. So plus 0. So we have now h prime of x is equal to 2x. Okay. Next, solving for the f prime of x, we have f prime of x is equal to, start with the h of x first. Our h of x here is x squared plus 1. So we have x squared plus 1 times g prime of x. G prime of x is 1. So times 1 minus our g of x here is x times h prime of x, which is 2x. Okay, all over h of x, 2x, okay, x squared plus 1 squared. Okay, this time let's simplify. So multiplying x squared plus 1 times 1, that is just x squared plus 1. And then multiplying x squared by 2x, that is negative 2x squared. So we have here negative 2x squared over x squared plus 1 squared. Next, combine like terms. So we have here x squared minus, so x squared minus 2x squared. We have here negative x squared plus 1 all over the quantity x squared plus 1 squared. This is already our final answer. Okay? You may have the denominator, you may expand the binomial in the denominator, but if it's not factorable, if there's no common factor with the denominator and numerator, then you may just leave it as is. Okay? So we can have this one as our final answer. Next, let's go to another example. We have here f of x is equal to 1 over x. All right? So in this example, our g of x is equal to 1 and g prime of x, derivative of a constant, is 0. Here, our h of x is equal to x and h prime of x is equal to derivative of x is 1. Okay, now we can proceed to finding f prime of x. So you have here f prime of x is equal to h of x is x. So you just write h of x times g prime of x, which is 0. So x times 0 minus our g of x here, which is 1, times h prime of x, which is also 1, over h of x squared. So you have here x squared. So simplify now. X times 0 is 0. Negative 1 times 1 is just negative 1 over x squared. And this is already our final answer. All right, so that is the quotient rule for differentiation.